Hello, everyone. Thanks so much for your attendance in this meeting. I'm Professor Julio Rezende. Today is March 4th of 2022. Okay, everybody, welcome to watch this presentation. Also, after our mission 107. Okay. In this case, I'll start my presentation talking about how a main station would be operating on Mars. In this case, in our missions, organized by Habitat Marte, we imagine a station on Mars with 7 facilities, and all of these facilities present some complementary functions. In this case, we imagine a station with a launch center, a main station, the health facility, the greenhouse, the sanitation center, the engineering facility, and the power station. Okay. In this presentation today, I'll be talking about the main station. Okay. Uh, in the process to create a station on Mars, we imagine that the main station is supposed to be the first model to be arriving on Mars, and after time receiving all the models connecting to the main station. Okay. My presentation will be talking about 5 topics. We'll be talking about the internal design, the applied technologies, the management, the protocols, and then also the spin-offs. The first topic is about the internal design. In this case, we had a participation of a architecture Brazilian student. Her name is Mariana Guerra, and she proposed something interesting, a modification from the original plan, not considering only one model but 3 models connected. Also, she did a consideration, also not a circular shape but hexagonal shape, like a comb. In this case, honeycomb. In this case, would be possible to connect the faces of these models. Okay. She called the models of alpha, beta, and gamma. Okay. And these 3 models presenting different functions. In this case, the first model, alpha, is a sector for resting and relaxing. The model beta is for entertainment and dining. And the third model, the model gamma, is to operate as a control center and it to support operations for the entire station. In this case, the alpha model, we have the bunks and the bedrooms and also a study room and restroom. And the second model, we have a kitchen, dining room, living room, and entertainment area. And the third model, we have a mission control center, training and research room. Talking more about the alpha model, we imagine a station with 28 astronauts in the entire station, and it's supposed to the astronauts return to the main station to sleep in the alpha model. In this area presents 14 bunks, in this case for 28 astronauts, also presenting 28 luggage storage, also 2 bathrooms and 1 study area, okay, in the alpha model. Also in the alpha model, we have the challenge about to cultivate plants aboard. Some reasons to about we have the plants aboard is related to evaluate their quality. Also brings nature to space habitats. This is also important for psychological well-being and less stress and more health and well-being. Possibility of vegetables produced in this facility be used to prepare meals, okay, using the concept of pick and eat. Also, these plants in the main station would be useful to help the meditation. In this case, we have like a concept of a dormitory or working as almost as a hostels, uh, as you can see around the world, okay, with some banks. Also, we need in the main station we have an area of reading and study room. In this case, it's supposed to be it's supposed we have physical books, just few of them, but also a lot of terabytes of informations of books and music and videos. Now talking about the second model, the beta model, is an area with kitchen and dining room. Also in the second floor, a living room. In the third floor, the gym. We participated in a immersion in a kitely environment, and this was a environment created by Michael Lowry, and the habitat created by him. It's he imagined like something like a swimming pool and also some music instruments, and this is a possible concept of an entertainment area. Also in this beta model, we have some fresh food, some plants, some spices that would be collected to prepare the meal. Also in the second photo is a robot from Molly Robotics. It's just a technology just available to be helpful to produce food, and also a concept of a dining room, how the dining room would be operated. Also the gym. The gym is very important to workouts, and the astronauts keep the good health conditions. Okay. And the third model, the gamma model, we have in the ground floor the research room, the second floor the training room, the third floor the mission control. In this case, we can see the evolution of the panels from the vehicles since the Apollo missions to shuttle and Dragon capsule. You can see the use of screens until the Dragon capsule. They using like a multitasking systems with multiple resources. And we're supposed to be using this kind of systems also to control different functionalities in the station on Mars. Uh, One of the important activities in the main station is control everything that's happening in the entire station. In this case, from main station, we have the contact with the greenhouse, with the power station, with health center, with sanitation center, to understand what is happening in the entire station. In this slide, we are considering a lot of topics to be controlled, and about we have the data and the information. From the greenhouse, we would like to know how is the temperature inside, how the greenhouse is demanding water from sanitation center. Okay, because if you have a limited resources like water, we need to manage very well. Okay, about not have a lack of water or lack of energy. In this case, the greenhouse will demand water and energy. You need to understand this. Okay. Also, something very important about the greenhouse is understand the food production, the quantity and quality of the vegetables produced in the greenhouse. Also, we are supposed the operation of aquaponic systems, and in this case, we have also the production of fish. In this case, you need to know the quantities of food produced in the greenhouse to be used in our kitchen, okay, to feed the astronauts. Also, you need to know a lot of information about the health of astronauts, how is the condition of them. In this case, you need to have the cooperation from health center to understand a lot of levels of indicators from the astronauts. We are imagining that on Mars, the astronauts is supposed to develop some diseases, One of most common disease to be developed by the astronauts is some kinds of cancer because of the extreme exposition to the cosmic radiation impacting the surface of Mars. In this case, you need to follow very well what is happening with the astronauts to understand some changes in the conditions of health of astronauts and try to identify the possible approach to keep the astronauts healthy. Okay. From the power station, we know that the power station is connected with solar energy. Also, it's possible to generate energy from the biodigester. Also, the solar panels, and need to know how much energy is generated from the power station center. Okay, and how is the consumption in the entire station? How is the demands for the extravehicular activities? Because the vehicles is supposed to be supplied by electrical energy and need to be charged. Also need to know from the engineering center if these vehicles we have like a nuclear cell. Okay, we need to understand this. Also, the sanitation center is supposed to be the most important facility in the entire station because it's from sanitation center where is generated the air, the oxygen to be consumed in the station. Okay. Also to recycle the water, two important resources for the operation of the station. In this case, if you have some failures in terms of generating water and also generate clean air to the astronaut, this would be very disturbing for the operation of, of the station. And we need to know how the sanitation center is operating. Also, from any station, we evaluate some weather conditions to understand if is the possibility of wind and dust storm, to understand if it's safe to develop the extravehicular activities. Okay, we imagine that the extravehicular activities is supposed to be very common to collect the ice in the landscape. Okay, the ice will be something very important resource for the station. Okay, the main station we have a research room to understand the spacesuit garment if it be damaged by regolith particles, considered very sharp. Also, soil analysis and other exams. Now I'll be talking about the applied technologies. We can see some machines and technologies used in the kitchen, like oven, fridge. Also technologies for entertainment area, like virtual reality headsets, also spa hydro message and disco lightning. In control center, communication technologies, antennas, and sensors. Some possible resources to generate in situ or transported for Earth. We can imagine that all of this equipment is supposed to be produced on Mars and transported to Mars. Okay, produced on Earth and transported to Mars. Okay, but some utensils would be 3D printed on main station. Okay, and part of the food will be produced in Mars greenhouse. Now I'll be talking about the management. For the operation of this station, we are imagining the 4 astronauts, in this case, two men and 2 women. In this case, the commander, the executive chief, the chef, and general assistant. In this case, the commander as a person that presents a multidisciplinary background, someone from management or industrial engineering, someone with a high capacity of leadership, intercultural competency, and high personal resilience. Some duties from the commander for this position is the commander will be controlling the extravehicular activities with communicating with engineering center. He will be controlling the rovers, okay, and all he needs to know everything related to extravehicular activities. We will propose routines and operational protocols, provide guidance to avoid risks, conduct educational activities, preparation for EVAs, coordinate daily communication routines with NASA, ESA, ISRO, and other space agencies from Earth, also with communication with mission control centers, facilities, also communication with the entire crew, and sometimes the communication with some specific astronauts. The second position is the executive chief. He is supposed to be, he or she is supposed to be an engineer, information technology specialist, or a psychologist. Some duties for the executive chief is to monitor all operation, keep all facility running, monitor routine maintenance, organize the specific operation, and identify the responsible astronauts, coordinate trainings, organize a specific operation, and responsible astronauts stimulate self-sustainability when each one is observing self-organization, self-maintenance, self-fixing, and alerting other astronauts. The third position is a very interesting position. Is the chef supposed to be a cooker, a cuisine chef, a nutritionist, or a gastronomer. Some duties are define the menu, the meals, the food logistics, before food preparation, waste disposal, cleaning, organization, also maintenance from the kitchen, assess the team's nutritional requirements, plan the viability of food, and define the feed shifts. We have the participation of Dr. Cyan Proctor. She's now a very renowned astronaut. She participated in the mission Inspiration 4 last September, and she participated in one of our virtual missions. And she presented this photo from the movie The Matrix. In the Matrix, there's a scene when the Neo he's in the ship Nebuchadnezzar, and he's complaining because all days the meal is the same, okay, and he's considering this situation very boring. He's complaining about, he's not happy looking for the same food all days. And Dr. Cyan Proctor was mentioning during her presentation that it's very important in the space missions. We have interesting meal and creative and colorful, and also a mixture, sometimes using different spices, food from different nationalities, to we have an interesting experience about the feeding moment, okay? And we consider that this very interesting. In this case, to feed the astronauts, we are considered part of our food will be transported from Earth, okay? You can see a lot of plastic package with, in this case, these are freeze-dried food, and there is an infusion of hot water inside these plastic bags when the food restores the original characteristics. In this case, we're supposed to be using the food transported from Earth, but also the food produced in the greenhouse on Mars. In this case, is a photo from some food produced on Habitat Marte physical facilities in our greenhouse. A photo from pepper and also lettuce and basil. The fourth position is an assistant. Is supposed to be an engineer, an information technology technician, a psychologist, or an artist. And some duties are emphasize the team's well-being, create interesting content to entertain the crew, also food management, support the chef, coordinate the organization of the dormitory, coordinate the team, and also manage laboratory tools, study routines, and sample analysis, also apply psychological surveys. Okay, in this case, these are the four positions to be of astronauts to be working in the main station. About some topics of training, we imagine the new skills based on situations identified on Mars, systems operation, new technologies, positions and tests of each astronaut, simulations, and also, not less important, the protocols. We identified some videos on YouTube about the team's work, about management of mental health. Also, we can imagine a lot of terabytes of music to entertain the crew. Also, the occupational safety and health, and also about the personal resilience. We imagined for to live in the during the day 1 kilo of solid food for one day, also 4 liters to drink, also 2.5 liters to prepare the meal, and 2 liters to prepare the bath, for the bath. Okay, in this case, we are imagine the kind of proposal to each astronaut. Okay, you need to multiply this quantity for the days that we are doing our quarantine time during this mission. Okay, some guidelines should be provided to other facilities. We imagine that from main station, you can provide daily guidelines about daily routines, also health occupation, also environment and safety guidelines, how to maintain plants in the specific habitats, guidelines about harmony and collaboration, how to let astronauts comfortable about to be in space, stimulus for cooperation, okay, also interesting content to entertain the crew, and also about self-sustainability. Now I'll be talking about the protocols. We imagine some specific routines are related to protocols to deal with stress, to organize the room, to plant maintenance, for food production, for infrastructure maintenance, protocols to save water, and protocols to save energy. And also imagine the protocols for safety and health related to hygiene protocols, also protocols to guiding about to collect the health data using wearables like Apple Watch. We need to know about the heart rate, calorie consumption, and physical activities from each astronaut. Also, other protocols about health data and protocols to deal with psychological balance and emergencies, and protocols and simulations to deal with accidents. About the entertainment, we imagine some happy activities like the celebrate the birthdays of astronauts, some parties, some celebration days like Diwali and Holi from India, also Dia de los Muertos, the Mexico, Carnival from Brazil, Halloween from United States, Christmas, New Year's, like Loser, also other dates, also related to the culture of the astronauts, but because you imagine astronauts from many nationalities in the station. In this case, all days celebrated on Earth would be supposed to be celebrated on Mars too. Also, new days that will be identified since we arrived on Mars. Also, spa day, board games, also yoga and workouts, also content suggestions based in terabytes of music, movies, and books. Okay, protocols for food microproduction. We consider the protocol for cultivation, for maintenance, for collection, harvesting, for rotation, best time for irrigation, male, female flower pollination, and plant cycle. Also, 3D printing, we are considering the possibility of use of ceramics, 3D printing for 3D printer for ceramics, also a plastic printer. Also, we have some examples of clay 3D printer and also using metal powder, okay, to print some utensils. For 3D printing, we imagine also a process to print based in many files of CAD projects, and also a protocol for degradation and recycling. For recycling, imagine the discarded items would ground down to particles. The ground plastics are further refined to smaller particles in a blender. The small particles are melted and extruded into a plastic filament for the 3D printed. And also in the last moment occur the additive manufacturing process with recycled filament. And now we're going to the last part of my presentation, talking about the spin-offs. We imagine that some technologies imagine to the operation of the main station, like technologies for sleep, for food production, and technologies for learning, and about save water, energy saving, and recycling. Some technologies just created would be applied to many communities. Okay. Also, you can see in the second photo the operation of the VEG inside the International Space Station. The first photo is showing a kind of equipment to help about the blood circulation, because in the process of microgravity, we don't have a good circulation sometimes of blood, and this equipment would be useful to help the circulation of blood in the body. Okay, also technologies for learning, we can imagine the use of virtual reality headsets. Okay, this first photo in this slide is showing environmental control life support system. It's a urine processor facility. This equipment was transported to International Space Station. It helps to recycle 70% of the water from the astronauts' urine. Okay. Also, other equipment to generate energy when we are walking. The last photo is a photo from a blender. Now we can imagine some guidelines to be applied to our daily lives on Earth. We can imagine that the astronauts inside the main station, they will be doing lectures and also recording videos to the people living on Earth, talking about health, environment, and safety guidelines. The astronauts on Mars will be talking about mental well-being. Also, they will be talking about daily routines and also the recycling mindset. And the last part of my presentation is talked about the impact in sustainable development goals. In this, you can see that our actions in the main stations are related to discussion about health and well-being. Also, when we are talking about training of astronauts, this is connected with a quality of education. Also, it's very important for us. We have a balance between women and men. In this case, if you have like four positions in this facility, supposed to we have two men and two women, and also maybe more women than men in the main station. Okay, like a commander be a woman, and this is important for the station. And also, it's very important also for us the attentions about water saving and also the energy saving too. Okay, the goals 6 and 7, because if you not have a good operation of this, the station would have some difficulties. Also, waste recycling. About something interesting about waste recycling, we imagine I show a photo from plastic bags inside the main station to pre-prepared meal transported from Earth. We consider that it's supposed to be interesting for the food package. We use a single plastic, okay, because it would be better to recycle a single plastics. Instead, we have many different plastics, okay. In this case, you're supposed to be recycling all the plastic bags transported to the station on Mars. Okay. Also, we have some learnings from related to management, associated to peace and justice, and also the importance of partnerships, because we imagine that a station like this, like in our mission, we have the people from many countries like Philippines, Mexico, Italy, and also Brazil, okay, and also India. In this case, it's very important we have this collaboration from people from many countries, okay? Okay, and also for water, we imagine the importance about communication and education about water, and also important procedures and techniques, treatment and storage technologies, habitat behavior, and the importance of maintenance of the facilities. Okay, these are my contact and Twitter and Instagram, and, and thanks so much. Okay, stop the recording. Okay, and thanks.